Hi, this is Sai Vodapalli. I'll be presenting you my understanding of the solution for assignment 5. So in this assignment, we'll be using the long short-term memory to predict the number of passengers in an airplane for the next day given the number of passengers today. So first to implement that, we just downloaded, we imported all the necessary libraries that we're going to implement. And then for the data set, the data set is at the given link. So we're going to import the data set into the airlines. And then once we imported the data set, we're just going to print the head of the data set. And then we're going to subset, we're going to visualize the first 40 samples of the data set. So to do that, here's the code given. So once we implement that, we are reading the CSV file into airlines, which has the data set, and then we are subsetting the size to 40 samples. Just we are going to visualize only the 40 samples. And we are using the matplotlib plot function to plot the data sets. We set the figure size as 14:4 and the DPI is 80, and then the plot range, and then so here, as we can see, we are plotting the values as plus symbol here. Okay, and then we label that as the passenger count. And then we are also using the alpha 0.5. So this basically draws the line. If I specify my alpha as 0, you wouldn't see any line. If I specify my alpha as 1, we will see a dark line here. And then we are also setting the X ticks. So these are the ticks. And then the range as the total number of subset sample that we took. And then we are also labeling with the months. And then we also set the rotation as 45. So that's why the labels are rotated 45 here. So implementing this, we just visualize the data like for 40 samples starting from 1949 January to 1952 of April. So as we could see, these are all the number of passengers that travel on each month. And so once we do that, so our next thing will be equal to extract the passenger column, and we're going to take a peek into it. And so to do that, we had the airline data set. We stored all that information in airline data set, right? So we're going to extract the passengers section from the airlines. And once we do that, we just print out a sample here. And then we are also converting the data set to float because we are going to normalize the data. So as we could see here, when we printed out the maximum value of the data set, we see the maximum is 622 and the minimum is at 104. So what we're going to do is we're going to implement the min-max scalar function to set the minimum to 0 and set the maximum to 1. So getting into the code, so here, this is how we implemented the scalar function, min-max scalar function. And then we specified our range to be 0 and 1. So that means our minimum should be 0 and our maximum should be 1. So that would scale 104 to 0 and then the 622 to 1. And then it will scale all the values accordingly. So once we do that, we are just printing out the data shape again. And also the max and min values of the data set just to verify whether it was performing accordingly. So as we could see, the shape remains the same, and then the data, so the maximum value for 622 is scaled to 1, and the minimum value 104 is scaled to 0. So once we normalize the data, we're gonna reshape the data, and once we reshape the data, our main objective or our program is to implement, our goal is to find the number of passengers will be, the total passengers will be in the next day based upon the features today, or based upon the values that we had today. We're gonna find the total number of passengers in the next day based on the passengers that we had today. We're gonna find, okay, by implementing the model, we're going to predict the passengers on the next day. So to do that, we're going to implement the lookback function. So here, the input feature will be X and the output label is Y, right? So based upon the previous value, we're going to look at the present value. So we're going to arrange the data in that way. So our X would be the previous day, and then the Y would be the next label. So we're gonna readjust those. So we're gonna move all the Y labels one step back to the left. So the previous day's feature will give you the next day's label, which is the next day passenger list. So to do that, there was this code that was already given to implement the lookback function. As we could see here, we are setting up the matrix X and Y here for the features and labels. And then we are implementing the lookback function for Y value and X value. And then the function is going to return X and Y. So what exactly this function does is if we give the data set, and specify like how long you want to look back. Based upon that, this will rearrange your data into features and labels. So we define this function, and then we are setting our look back as 1. And then the data set that we got, the LN data set that we had, we're gonna send it to the function with the lookback value set to 1. So once we do that, once after rearranging the data, obviously we will lose the first set and the last point. So that's why initially it was 144, and now after rearranging the data, the features and the labels we got as 142. So we're gonna use these features and label, this data set to train our model. So again, to train the model, we're going to split the data into 70 and 30%. So 70% will be our training samples, and then 30% will be our testing samples. And then just we're going to use the random state of 42 just to have the same samples. So same set of samples distributed. So using the train test split sample, and then from the previous code, we got the features in data X and the labels in data Y. So from data X and data Y, we are specifying the test size as 30% or 0.3. And once we do that, and also we are implementing the shuffle function, so it shuffles the data. And based on that, it's going to split, and we print out the shapes of the training and test samples just to verify whether the train test split performed its function. So as we could see, there was like 142 data set points, and 70% of 142 came out to be 99, and then the 30% of 142 came out to be 43 data points. So now we got our trains data and the test data. So now we're going to implement the Lstm. So to implement the Lstm, we're going to define the sequential. So here we are specifying function asks to build a Lstm model with the layer set to 100 units. So it's going to iterate like 100 times. And then we are also specifying the input shape, and then also the dense layer with 1 unit. So to do that, when we look at the code here, so we specify the Lstm sequential, and then we added the Lstm with 100 layer with 100 units. And then we specified the input shape as 1, and then the look back as 1. So its input shape is 1,1. And then the add dense as 1. So here, when we don't specify the activation function, it by default takes ReLU. So once we implemented the sequential function, we're going to close it, and then we are also compiling the function by setting up the loss as mean squared error. So here we are setting the loss function as mean squared error because since it is a regression model, we're going to use mean squared error, or we could use root mean squared error. If it is a classification, then we're going to implement like categorical cross entropy. And we're also specifying the optimizer as Adam, which is very good optimizer for initial data. And then, so we're going to fit our model for training samples. And we're also specifying our box as 10, and then the batch size as 1, and the verbose 2, which just gives the extra information like the processing information. So as we implemented the Lstm model here, we could see the total number of parameters as 40,901. And then there were like 10, the model ran for 10 epochs. So we could see clearly for each epoch, the loss function is going down. So that clearly indicates the model is learning and the accuracy of the, the accuracy is getting better for each epoch. So once we train the model, we're going to implement so once we train the model, we're going to predict the training samples and also the testing samples and see how well our model got trained. So to do that, we are implementing the Lstm.predict function and giving it the extrain samples. And then we got the predict train. And then same for the X-test, we got the predictor values for the test samples that we gave. And then, so here we got the, since our data is normalized, we got the normalized data, like, all the values will be between 0 and 1. But in order to get the actual number, we're going to implement the scalar inverse transform. So it's going to be the same function that we used for normalization. It's just going to reverse the normalization. So from 1, let's say if the value is 1, it means 622, and if the value is 0, it was 104 passengers. So based upon the value, based upon the predictor train values that we got, implementing the scalar inverse transform, it's going to convert this normalized data into the original data. So once we do that, we're going to do the same thing for train and test, because our train and test samples are also normalized. And then we're going to, get the original data. And then we're going to compute the mean square error here. So to do that, we are implementing the mat.square root of mean square error of y train and predictor train samples. So we're going to look at the original train samples and then the predictor train samples and compute the mean square error. So and then same thing, we're going to do it for the testing samples. So we're going to look at the test values and then the predictor values, and then we're going to compute the mean square error for test values too. So once we do the root mean square error, as we could see here, the root mean for the training samples, it's about 34.4, and then for the test samples, it's about 33.6. So that means there is a error of like 34. I mean, there is a root mean square error of like 34 passengers in the training samples and then about 33.6 passengers in the test samples. So now we're going to implement the plot function to really to visualize the data. So to do that, here we had already given the code. So when we look at the code, as we could see, we are plotting two figures, one for the training data and one for the testing samples. And then we are setting up 0 for predictions and X for ground truths. And then as we could see, and then we are plotting for train and test samples. As we could see here, the graph. So the X represents the real values, like the original values in the training samples, and then the orange dot represents the predictor values. As we could see here, there's a difference between the predicted and the original values of the ground truth values. So the mean square error would implement a function like calculate the difference between those two, square the difference, and then divide it by and sum all the differences and divide it by the total number of the differences that it calculated. So for the training, we got it like 34, and then for the test, as we could see here, there is a difference between the real value and then the predicted value. So same again, we're going to calculate based on the difference between the real value and the predicted value. It's going to square the difference and then add all the differences and divide it by the total number of samples. I mean, like total number of differences that it got. And we got our root mean square error for test sample was about 33. Thank you.